Hi everybody. So now that we know what exponential and logistic functions are, it's time to see them in practice and kind of get a handle on the math that we need to do to actually utilize these things. So let's jump in. So one type of question that may come up is just remembering your exponent rules, because it's been a while since we talked about those, but you should be able to calculate the answer to a problem like this and not need a calculator at all. Let's see if we can do it. So the question is saying here we have an exponential function, and we know that because the variable is in the exponent, right? But what they want us to do is evaluate this function if x is -2. So I always start off by saying, here's what I'm about to do. I'm going to plug -2 into my function. So that gives us -2 times 5 to the -2. So this is a great time to remember, what do negative exponents mean? And also, what does order of operations say here? Now, I know some people would look at this and say, oh, okay, well, -2 times 5 is -10, and then we'll square it and what, but ooh, wait. Order of operations says exponents happen before multiplying. So we have to make sure that we are dealing with that part of the problem before we do any multiplying. So order of operations always holds no matter what. Okay, so 5 to the -2, what does that mean? Well, we know what 5 to the second is. It's 25. The negative exponent does not make it into -25. What it does is it flips that 25 over. So 5 to the -2 is 1 over 25. And now I can finish up by multiplying and get -2 over 25. Now I know you could say, well, I could just put that in the calculator. You could, but then you wouldn't be using the calculator between your ears, and that's what we're trying to get to grow this year. So that's how we evaluate without a calculator. Easy enough. So let's think about graphs. So this time we are given the graph and they are asking us for what the equation is. That's kind of backwards for what we usually see, but can we create an equation when all you see is a graph with two values? And the answer is, of course we can. We need to remember though that exponential functions have a basic format or a basic structure, and this is what it looks like. That's where we need to begin. Now, the first thing I'm going to need to do is figure out either A or B. How do I know where to start? Well, we're going to start with this point here because I'm kind of thinking that might be my key point. It's kind of looking like we have 0 and we get a -1 as a result. That looks like a key point to me. So here's what I'm going to do. I'm going to plug that point in for x and y, and let's see what happens. So the y is -1. I don't know A, I don't know B, but I know x is 0. I see what's happening here. So b to the 0, that's just 1. So basically what I just found out is that the A value for this function is -1. And remember we talked about that A is actually your original amount at time 0. So looking at this function, I would have known immediately A is -1, but I just showed you why it's -1. So that's kind of cool. So this is where we are with our function right now. A is -1, and then we have B to the x. So really the only thing left to do is figure out, so what's B? Well, I think that's probably the purpose of this other point they gave us. And this should be looking kind of familiar. We've done this now with polynomials, we've done this with quadratics, we've done this with lines, where they give you a point on the curve to help you find something in the equation. So we're going to plug in the -e² for the f of x. That's my y value. I don't know what b is, but I do know that x is -2. So can we figure out what b is from this? And the answer is absolutely we can. The first thing I notice is both sides are negative. So I'm going to make those into plus signs just to make life a little bit easier. And I'm also going to remember that a negative 2 exponent means flip it over and square it. So I'm going to write b to the negative 2 as 1 over b squared because that's what it is. I'm starting to see something happening here. So what if I flipped both sides over? Is that legal? Am I making up math? And no, I'm not making up math. It is totally legal to flip both sides over as long as you do it on both sides. And I think I now see what b is. It's going to be the square root of 4, which is 2, and the square root of e squared, which is e. So now I know what b is. So now I can finally write my function. So f of x is the a value, which was negative, and then the b value, which is 2 over e, and that's to the x. And that makes sense, right? We have a negative in front, which means flip over the x-axis. This graph is definitely flipped over the x-axis. And 2 over e, well, that is a number smaller than 1. So originally this graph was decay. It was something up here, and it got flipped over the x-axis to become the graph that we were given. Cool. So basically, when you are given points on a curve, you just need to plug them into the basic structure of the equation, and you can solve for everything you need. Awesome. Let's see what other cool stuff we can do. So another thing we can do sometimes is talk about how we can transform one graph into another. So in this case, we're given e to the x. Now that is just a very straightforward, basic exponential growth curve, right? And it goes through the point 0, 1, as they all do, and that's what e to the x would look like. Somehow, e to the x has become g of x, which looks a lot more complicated, and they're not really asking us to graph g of x. They're asking us to describe in order what's happening to f of x to make g of x. So it's all about knowing what those numbers in this equation are representing. So remember, transformations do have an order. The first thing we look for are stretches and smushes. In this problem, I see 2 of them. The 4 represents a stretch or a smush, and so does that 2. So we've got 2 things going on. Well, we talked earlier about numbers out front are vertical stretches and smushes, right? So we're going to say vertical to be very specific. And is it a stretch or is it a smush? Well, the rule is numbers bigger than 1 are stretches. So we are doing a vertical stretch with that 4. Now the 2 is actually a horizontal change because it's in the exponent. And the rules for those are opposite. So that 2 is not a stretch, it is a smush. So we're basically vertically stretching the graph and horizontally smushing it together. So imagine like it's a big piece of Play-Doh. Okay, so that took care of those 2 things. Then the third thing that's happening, the only thing left, is a -3. So that means that this graph is going down 3 because that number is at the end. So now we're not quite done though. They're saying, all right, well, we've listed in order what happened, but what happened to 0, 1? That's the question. So let's follow that point around. So remember we learned when you vertically stretch an exponential curve, you are also stretching the key point. You are multiplying by 4. So our key point is now at 0, 4. That's our new original amount. What about horizontal smushes though? Let's think about this. So if you have a curve that is going through a certain y-intercept, and you make that curve more steep because you're smushing it toward the y-axis, did you move your y-intercept? And the answer is no, you didn't. It's going to stay at 0, 4 even after the horizontal smush happens. So vertical smush or stretches either. Vertical does change your key point, horizontal does not. Very important thing to know. Now we have to move this point down 3, so that's going to put me at 0, 1. So if I were graphing this, my final key point would be labeled 0, 1. Cool. Let's keep going. So now we're going to talk about a logistic curve. And we are asked to do a few things. First of all, graph it, but also talk about its domain, its range, asymptotes, and all those things. So let's first of all make sure it's in the correct format. So just to remind you, for exponential functions, that would be c over 1 plus a times b to the x. Well, I definitely see a number on top. I see 1 plus, and then I see an exponential function on the bottom. So that's cool. So everything's looking good. That tells me a few things right away. The first thing it tells me is the domain. In fact, I didn't even need to do that to figure out domain, because for logistic functions, it's all real numbers. You can plug in anything for x that you want, and you'll get an answer. Now the range, that's going to take a little more thinking. So let's think about our asymptotes first. So what we know about logistic functions is there's always a horizontal asymptote at 0. So I can go ahead and draw that in, because you can't have negative people infected with a disease or negative people hearing a rumor or anything like that. So we know that we're definitely going to have something happening at 0. The other asymptote, though, is the number in the numerator. For us, that means y equals 12. So I'm going to, I think we're going to be numbering by 2s here. So 2, 4, 6, 8, 10, 12 means my other horizontal asymptote will be right there. And that is the value 12. So now that we know that, now we can get the range. If your asymptotes are at 0 and 12, that's where your entire graph will be. So your range is from 0 to 12. So that's kind of cool. Okay, they also want to know what our y-intercept is. So to get a y-intercept, that means we have to plug in a 0 for the x, right? So for my y-intercept, I will have 12 over 1 plus 2 times e to the 0. So what does that make? Well, that's 12 over e to the 0 is 1. So 1 plus 2 makes 3. And so I get 4. So the y-intercept is the point 0, 4. So this is where we're going to cross the y-axis. And once we know this, we are good to go with drawing this curve in. We know where we cross, we know what we get close to, and bam, you just created a logistic function. Awesome. Now there is one thing left to do, and that is to describe the end behavior using limits. So we're going to write these right on the bottom here. This function is called g. So if I think about what is happening in this graph at infinity, which is over here on the right, we're getting close to 12. So my end behavior is 12. On the left side of the graph, as we head toward negative infinity, so we're over here, this graph is getting close to 0. So my end behaviors are the asymptotes. And there you have it. We have graphed our function and described all of its characteristics. So our last problem is going to be a little bit more open-ended. We are going to take a real-life scenario and try to create an equation for it. So we may not know all of the numbers, but we can do the best we can. Let's read what's happening. On a certain day in school, 2 friends share a rumor and then start spreading it around the school. The school population is 750. So let's take a look again at what a logistic function has to look like. So what do we know that we can plug in? Well, one thing we know is this 750. That's going to be the upper limit, right? Because if it's all being contained within the school, there will not be more than 750 people knowing about it. That's telling me 750 is the C value. So at least I know that part. The other thing they tell us is that on this certain day, 2 friends are talking about it. So at time 0, 2 people know the rumor. That's my y-intercept. Now that means if I plug in a 0 for x, I have to get 2 as my answer. There are many, many different things I could do to make this happen, but we have to get 2 as our answer. So let's think about this. I want 2 to be the result. I know I have 750 on top. And then I have this 1 plus a times b to the 0. So b to the 0 is just, that's 1, so it's gone. So basically what I need to do is figure out, what does a have to be? Okay, well, let's multiply both sides by 1 plus a. So we have 2 plus 2a equals 750. So 2a is going to be 748. So we divide by 2 and we get 374, I do believe. Whoops, I didn't need that 2 in front there. So a is 374. So if I divided correctly, I think I did, that's what we get. So that's what a has to be. So do we know what b has to be? And the answer is no. We know b has to be a number less than 1, so we get growth. But other than that, b could be anything. So that means I'm pretty open. So I know 750 must be on top. I know 374 must be here to give me that split that I want, right? And let's just pick a number. Let's say 1/2. That will be the b. And I have created a model for the spread of this rumor. That's pretty cool. So really, that's kind of thinking that we can do. If we know some information, we can make an equation, even if there's a little bit of a question mark, like with the b value here, we still were able to figure out an equation to model what's happening. That's pretty awesome. So this should give you some direction in doing problems. And so we'll talk in class some more about what things might be confusing. But hopefully this gave you a lot of insight. Have a good one, everybody.